All right, you guys. So today we're going to be talking about limiting reactants. And just keep in mind that this is something that we've actually done already in the lab that we did where we made silver. So I'll be referencing that from time to time. So I'm going to jump right in here. The first bullet point says, unless you have a perfect mole ratio of reactants when performing an experiment, which we did not have, one of the reactants will get used up first. Used up. All right, in our lab, we used silver nitrate and copper wire. And if you remember, we pulled the copper wire out and there was a bunch of copper wire left. So that did not get used up. What got used up was the silver nitrate. So this reactant has a name and we call it the limiting reactant. Sometimes it's called limiting reagent, but we're going to call it limiting reactant. So it's the one that limits how much product we can make. Excuse me. The other reactant, the one that is left over, like the copper wire, that is called our excess reactant. So it's called excess because, just like in our lab, there was some excess left over. There was some copper wire that was left over. So that was considered our excess reactant. And the amount of silver that we made was determined by the limiting reactant. So how much we can actually make of something is always determined by that limiting reactant. That really dictates how much of something we can make. Okay, and remember, stoichiometry is all about like making stuff. So we want to mix a bunch of reactants together and make something. We made silver in the lab, but we can make anything. All right, so back to our food analogy. So we have a recipe here that says I need 1 cup of flour, 2 eggs, and a ½ teaspoon of baking powder. And if I mix those 3 ingredients together, or those reactants together, I will make 5 pancakes. That is my product. Here's sort of what would appear to be like a balanced equation with our coefficients, 1, 2, 1/2, and 5. Okay, so that's our ratio. Now, here's the question. If you start with 3 cups of flour, 10 eggs, and 4 teaspoons of baking powder, how many pancakes can you make? Okay, so let's think about that for a second. How many pancakes can we make? Well, if you think about it this way, if I start with 3 cups of flour, how many pancakes can I make? Well, for each cup, I can make 5 pancakes. So I can make 5 pancakes with that cup. I can make another 5 with that cup. And I can make another 5 with that cup. So my ratio here is 1 cup will make 5 pancakes. 3 cups will make 15 pancakes. I'm just going to put cakes. All right, now we do the same thing with the eggs. If I'm going to start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I have 10 eggs here. Well, my ratio says for every 2 eggs, I'm going to make 5 pancakes. So every 2 eggs, so there's 1, 2 eggs, that's 5 pancakes. Here's another 2 eggs, that's 10 pancakes. There's another 2, that's 15. Here's another 2, that's 20. And there's another 2. So I can actually make 25 pancakes if I just look at the amount of eggs that I have. Okay, now the same thing with my ½ teaspoon of baking powder. Let's just say that these are each ½ teaspoon. So a ½ teaspoon makes 5 pancakes. So ½ teaspoon makes 5. Another ½ teaspoon, I can make another 5. I can make another 5 here, another 5 here. So there's 20. So if I just look at my baking powder, I can make 20 pancakes. Okay, now the question says, how many can you actually make? What's our theoretical yield here? Well, this might be pretty obvious. We can only make 15 pancakes because we run out of flour. There's no flour left. So the flour is what we would call the limiting reactant. Okay, I'm just going to abbreviate that LR. So we can only make 15 pancakes. Remember, this is also known as my theoretical yield. In theory, according to the recipe, I can only make 15 pancakes because I run out of flour. I will have some eggs left over and I will have some baking powder left over, but I won't have any flour left over because I used it all. All right, so here's how we sort of figured this out. So that's a nice analogy because it's very visual and I can see, okay, that makes sense to me. But you know, in a chemistry world, you're not going to be able to see the ingredients. You're not going to be able to see the product. You might be able to see it, but it's very hard to visualize, well, how much did I actually make? So we're going to use a different method. We're going to use the same idea here where we're going to figure out how much each of these reactants can make. And then remember, we're always going to choose the smallest product. Okay, the smallest product will tell us what the limiting reactant is, whichever one produces the smallest product. All right, so if we go down to answer these questions, what is the limiting reactant? Well, that was our flour, okay, because it got used up. What was excess? Well, we had some eggs left over, and we had some baking powder left over. Okay, so those again are called our excess reactant because they did not get used up. How much of the limiting reactant is left over? Nothing. We don't have any flour left. How much of the excess reactant is left over? We could go back and do the math here. We're not too concerned with that, but if you are curious and you want to go do the math, we actually will have 4 eggs left, and we'll have half a teaspoon of our baking powder left after we make those 15 pancakes. Okay, again, that's not as important as understanding what is the limiting reactant, what is the excess reactant. All right, so some vocabulary here. Theoretical yield. So we've talked about this before. It's the amount of product that you should be able to make based on how much of that limiting reactant we started with. If you remember in the lab, we started with like 0.70 grams of silver nitrate, and I said don't use more than that. That's because I knew that was going to be the limiting reactant, and so that's going to tell us how much silver we make. So the theoretical yield is the calculated amount. How much product am I supposed to make according to this recipe or this balanced equation? The actual yield is, we call it in the lab, we called it the experimental yield, but it's also called the actual yield. So you can call it either one. And it's literally how much did I actually make. So when you guys made silver, you came up with a number that said, here's how much we actually made. We heated it up, we scraped it into a little dish, and we weighed it. And this was our actual yield. We also called it the experimental yield. Okay, and then if you remember, the last thing you did is you calculated a percent yield. You basically compared, here's how much I made, here's how much I'm supposed to make, what's my percent yield here? So we'll do that in a second. All right, so you can use these notes on the quiz that we're going to have on whatever our next class period is, so just to point that out. So I broke this down into steps just because it seems like that's a little easier for some of you guys. So the first step, again, just like what we did before, is writing out the balanced equation. Okay, well, it tells us that aluminum and oxygen, those are our 2 reactants. So I can write aluminum and oxygen. Those are my 2 reactants. It also tells me that we are producing what is the theoretical yield in grams of aluminum oxide. That is our product. If you remember, aluminum on the periodic table is +3. Oxygen's -2, so if I crisscross those, I get Al2O3 as my correct formula. Okay, let me change the color here. Let's go with green, just for the balanced equation. So because I have 3 oxygens on the right and 2 on the left, I know there's going to be a 2 right there, which means that's going to be a 3. So now I have 6 oxygens, 6 oxygens. 2 times 2 is 4 aluminums. So I need to come back over and put a 4 there. So now my equation is balanced. But I always have to start by making sure I have a balanced equation. All right, step 2. I want to calculate how much product can be formed. I want to calculate the theoretical yield of the product. So what is given? Now here's the only difference between what we have already done and the new stuff. So the only difference is now we are actually given two separate amounts. Okay, in the previous stuff that we've done, you've only been given one thing. Now we're given two things. And what I want to find is, what is the theoretical yield in grams? So I want to find the grams of aluminum oxide. Okay, so I know what the given is. I know what I need to find. Now I'm just going to set this up the way I normally do. So there's a mass. So I've got 50 grams of aluminum and 46.0 grams of oxygen. Okay, so I'm going to set this up. My first step, I'm going to put grams on the bottom, grams of oxygen on the bottom. And if you remember, the first step is always to convert to the mole, because my recipe or my balanced equation is in moles. So I need to convert that. So here's the periodic table. I'll do this for you guys. So 26.98 and 32.00. Okay. And I'm going to close my garage door because the ice cream lady is coming. All right, you can probably hear her in the background. But that first step, if you remember, was always right off the periodic table. Okay, now my next step, I'm going to put moles of aluminum on the bottom, moles of oxygen, and now this is where I'm going to use the mole ratio right off the balanced equation. Man, she's got that music rocking today. Okay, there we go. So again, periodic table was the first step. Second step, mole ratio right off the balanced equation. So I'm going to go back up to the balanced equation, which is in green. And I'll change the colors just so we can see where we're getting that from. But if I go back to the balanced equation, I have a 2 in front of the aluminum oxide. So 2 moles of aluminum oxide. I have a 4 in front of the aluminum. So that's a 4. And then the bottom one, again, I have 2 moles of aluminum oxide and then 3 moles of oxygen according to that balanced equation. Okay. So we did periodic table, then we did balanced equation, and now we're going to go back to the periodic table because we're going to convert this back to grams. So I know moles of aluminum oxide has to go on the bottom. And I want to convert that to grams. Aluminum oxide. Grams, aluminum oxide. Okay, so I know that 1 mole of anything on the periodic table equals the molar mass. And I will add this up for us. So I go to the periodic table and I add up 2 aluminums and 3 oxygens. And I get 101.96 for both of these. Okay, so hopefully this is a review. We haven't done anything different. The only thing different is we're starting with 2 different numbers here. Okay, that's the only thing that's different. Everything else is exactly the same. Periodic table, balanced equation, periodic table. I really should cancel out my units as I go through and do this. So let me cancel these guys out. Cancel, cancel. I should be doing that as I'm working through the problem. All right, now if I calculate this out, I should get 94.5, I believe, grams of aluminum oxide for this guy. And if I do the calculations correctly here, I should get 97.7 grams of aluminum oxide. Okay, now, if you get this far, this is great. But this is where I see a lot of mistakes happen. Because now, a lot of people get stuck because they're like, well, the original question says, what is the theoretical yield in grams of aluminum oxide? I actually have 2 answers. I have this answer here in grams, but I also have this answer here in grams. What do? So remember, if we go back up to the pancake analogy, I had 3 answers here. We could have made 15 pancakes, 25 pancakes, or 20 pancakes. How much did we actually make? We made 15 because it's the smallest number out of the 3. So we're going to use that same approach here. The smallest of these 2 products is 94.5. So that is how much product we actually made. That is our theoretical yield of aluminum. I'm trying to write and talk at the same time. That's our theoretical yield of aluminum oxide, 94.5 grams. Okay, so that answers the first question. Step 3 says the smaller of the two answers is the amount of product that will form, and it comes from the limiting reactant. So the limiting reactant, so we answered a lot of questions here. So it's more just a matter of like understanding how to read this once we do all the math. So again, the smaller of the two answers is our theoretical yield, okay? This also tells us that the limiting reactant comes from the one that produces the smaller amount of product. So that means that aluminum is our limiting reactant, and that means that oxygen is our excess reactant because it actually made more. Just like in our example up here, flour was the limiting reactant because it got used up. It produced the smallest amount of product. We still had some eggs left over, and we still had some baking powder left over. So those are called the excess reactants. All right. And this mistake comes up a lot where people say, oh, this is the limiting reactant right here. That is not a reactant, that is a product. So the reactant is aluminum and the excess reactant is oxygen. Okay, now how to determine the percent yield? I'm going to take the actual yield. Now remember, that's the same thing as my experimental yield. And because I didn't do this in the experiment, they have to tell me what that is. So right below that it says, while performing this experiment, a student produces 35.8. That is my actual yield. That has to be given because we did not do this in the lab. So 38.5 is my actual yield. The theoretical yield is what we just calculated. It's 94.5. It's the smaller of the two numbers. So 94.5 grams. Remember, that's what we are supposed to get in a perfect world. We actually got 38. This is not a good percent yield at all. We lost a lot of product somewhere in the process. But if you calculate this, you should end up with 40.8% yield. That is a horrible percent yield, and you will be fired if your job is just to make aluminum oxide all day long, and that's how much you actually make. That would be bad. You want to shoot for about 90% yield. That's considered pretty successful. Okay, so we got theoretical yield and our actual yield. All right, now it's time for you guys to practice one. So if you can do this from start to finish, you are ready for the 2 practice questions that I have for you for homework. And again, you can probably pause this video and just practice it on your own first. I would strongly recommend you do that first before sort of listening to this. But I'm going to go ahead and work through this. Okay, so I already have a balanced equation. Step 1, check. Step 2, I need to indicate what is given and what I'm trying to find. So in this case, what is given is 2 numbers, right here and right here. So I'm given 45.8 grams of NO, and then I also am given 12.4 grams of hydrogen. Now, what do I want to find? Determine the theoretical yield of ammonia. Okay, so there's 2 products here. There's water is one of the products, so that must mean by process of elimination, that must be ammonia, and it is. NH3 is called ammonia. So I'm trying to find the grams of NH3. Okay, so once I do that, that's step 1 and part of step 2. So now step 2 is I'm going to set up my dimensional analysis. I'm going to do this one. I'm going to do this one right below it. H2. Now, first step, I'm going to do both of these at the same time because personally I just think it's a little bit easier that way. Okay, and I'm going to do this. I'm just going to set up the skeleton here because I know this is going to be 3 different steps. I also know it's going to be periodic table balanced equation, and then periodic table. So I'm going to do grams of NO, and I'm also going to do grams of H2 because I know that has to go on the bottom. I know I need to convert these to the mole first. 1 mole, H2. And now I'm going to go periodic table. I'm going to add up nitrogen and oxygen. And if you do that, you will get 30.01. This one's going to be 2.02. Okay, and I'm going to cancel as I go. So cancel out the grams. Now I'm at moles of NO. I know I need to put moles of NO on the bottom of the next step, moles of H2 on the bottom of the next step. And now I want to get to ammonia. So I'm going to do the mole ratio right off the balanced equation. Okay, NH3. So I'm going to go back to my balanced equation, and it says for every 2 moles of NH3, I need 2 moles of NO. Okay, and also balanced equation, 2 moles of NH3, I'm going to need 5 moles of H2, according to those coefficients in the balanced equation. All right, cancel, 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 cancel. So now I need moles, NH3 on the bottom, moles, NH3 on the bottom. And I want to convert that to grams of NH3, so I'm going to put that on the top. NH3. Okay, 1 mole, 1 mole. Again, I go back to the periodic table. 1 mole of anything equals the molar mass. So I'm going to add up 1 nitrogen and 3 hydrogens, and that comes out to be 17.04. Now when I do all the calculations, I'm going to get 26.0 grams of NH3 for this top one, and I'm going to get 41.8 grams of NH3 for the bottom one. Okay, now remember, step 3, the smaller of the 2 answers is my correct answer. Please do not add these together. Don't take the average. It's always the smallest. So again, this is what's considered my theoretical yield. Theoretical yield. So in theory, we should be able to make 26.0 grams of NH3. So that is my answer to letter A. Letter B says determine the limiting reactant and the excess reactant. Remember, the one that produces the smaller amount, that is my limiting reactant. Okay, so NO, limiting reactant, equals NO. My excess reactant is the one that produced the larger product. So that is my H2. All right, and remember, those are my reactants. Okay, the last one says calculate the percent yield for the reaction. And again, they're giving me the actual value, which is 24.2 grams of NH3. So I'm going to do my actual value, 24 point, what was it, 2? So 24.2 grams was my actual value. My theoretical, which is what I calculated, is 26.0 grams. I multiply this by 100, and I get 93.1% yield, which is very good. Percent yield. There we go. Like I said, anything over 100, or no, anything over 90 is considered really good. Can you get over 100% yield? Absolutely. Some of you guys saw that in the lab. Is it possible? Not really. Usually what that means is your actual value, like your silver that you recovered, there was some water in it. So it actually weighed more than it was supposed to. So don't get excited if you see more than 100% yield. That generally can't happen.